Hello, class. Today we're going over 8.5, adding and subtracting rational expressions. So when we are adding or subtracting rational expressions with like denominators, which means that the bottom of the fraction is the same, we would add the numerators and keep the denominator the same. So you combine the tops, but the bottom just stays what it was in the beginning. So let's go ahead and practice a couple problems like this. Our first one is 12 over 5x minus 2 over 5x. Notice the bottoms are the same, so we're going to add across the top, or in this case, subtract. So it'd be 12 minus 2 on top over that 5x. 12 minus 2 is 10, so I get 10 over 5x. Now our last step is to make sure we can't simplify anymore. In this case, 10 and 5 are both divisible by 5, so we would want to simplify it to get 2 over x is our final answer. For the next problem, 3x over 2x plus 5 plus 1 over 2x plus 5. Notice denominators are the same again, so we would add across the top. 3x plus 1 over, the denominator stays 2x plus 5. And since there's no factors for both of these that are the same, this is our final answer. Now, there's a couple more steps when we're adding or subtracting and the denominators are unlike. So if we have unlike denominators, we first want to find a common denominator. Your next step is to rewrite expressions using the common denominator. And then your last step is to add or subtract. So let's look at some problems like this. In example 2, this first example, we're going to go over adding 3 over 10x squared plus 2x over 5x squared minus 10x. Now, the first thing I usually suggest doing is factoring out anything that can be factored to look at the denominators and pieces. So as an example, 5x squared minus 10x, I can factor that into 5x times x minus 2. Now, I also know for 10x squared, I can take out a 5x out of that as well, and that gives me a 2x. So for a common denominator, they both have 5x, so we need a 5x. Now that first denominator also has a 2x, we need that, and the second one has an x minus 2, we also need that. So our common denominator is the 5x times the 2x times the x minus 2. So this ends up being 10x squared times x minus 2 is our common denominator. So in order to get that, for this first fraction, the 3 over 10x squared, I have to multiply it by that x minus 2. And whatever I do to the bottom, I have to do the top. For the second fraction, it's missing the 2x. So I have to multiply top and bottom by 2x. And if it makes it easier to see and understand, you can keep this denominator in factored form, which is 5x times x minus 2. Okay, so now for the next step, I'm going to go ahead and multiply everything out. So x minus 2 times 3 on top, so 3 times x minus 2. On the bottom, it becomes that 10x squared times x minus 2. Plus, for the next fraction, 2x times 2x is 4x squared. Over on the bottom, the 5x times 2x gives us that 10x squared times the x minus 2. Okay, so now they have the same denominator. We want to combine along the top. I am going to go ahead and distribute as I combine. So I have 3x minus 6 plus that 4x squared all over 10x squared times x minus 2. Now you would rearrange the top in descending order, 4x squared plus 3x minus 6, and then make sure you can't factor to cancel anything else out. So to tell if this is factorable, you can use the discriminant b squared minus 4ac. So 3 squared minus 4 times negative 6. So 9 plus 16 times 6, which is 96. So that gives us 105. That is not a perfect square, which means this isn't factorable, and this will be our final answer. Okay, for the next one, we're going to subtract. I'm going to follow the same process where I'm going to try and find a common denominator first. So I'm going to go ahead and factor the bottoms. For the bottom of the first fraction, it's 3 times x minus 5. For the second one, I get x minus 5 times x plus 1. So then for our common denominator, they both have an x minus 5. We need a 3 because it's in the first one. And we also need an x plus 1 because it's in the second denominator. So our common denominator is 3 times x minus 5 times x plus 1. That is what we're trying to get in the bottom of both of these fractions. So looking at the first fraction, we have the 3 and the x minus 5. We're missing the x plus 1. So I'm going to multiply top and bottom by x plus 1. For the second fraction, I'm going to go ahead and write it down first. And I'm going to keep this in factored form. Notice we're missing the 3, so I'm going to multiply top and bottom by 3. So when I multiply it out, I'm going to go ahead and distribute this. So I get x squared plus x. The bottom I'm going to leave as 3 times x minus 5 times x plus 1 minus. This 3 does have to be distributed to everything on the top of the second fraction. So it becomes 6x plus 6 over 3 times x minus 5 times x plus 1. Now that they have common denominators, we can combine the tops. When we do that, it's x squared plus x. The minus applies to everything in that second fraction, so it becomes a minus 6x minus 6. You do have to distribute the minus sign. The bottom is still 3 times x minus 5 times x plus 1. If we simplify the top, we get x squared minus 5x plus 6 all over 3 times x minus 5 times x plus 1. Now there's no way to factor the top that would help us simplify any further. So this is our final answer. Next, we're going to go ahead and take a look at dealing with complex fractions. Now, a complex fraction is a fraction that contains a fraction. Okay. And when we have this issue, when we have a fraction that has a fraction in it, we want to resolve that issue, right? We want to get rid of the fractions within the fractions. So we're going to go over how to do that today. There are two methods. The first is to simplify the numerator and denominator of the big fraction by writing each as a single fraction and then divide them. Method 2 is multiply the numerator and the denominator by the least common denominator of all the fractions and then simplify. So we'll go over both methods today. I'm going to use method 1 and example 3. So for method 1, we're going to go ahead and combine those two fractions that are in the denominator first. So we're going to combine these two. Okay, so to do that, I need to get common denominators for the bottom. So notice I have an x plus 4 and an x. So a good common denominator would be x times x plus 4. Okay, so I'm going to keep the top the same for right now, 5 over x plus 4. On the bottom, to get those two fractions to have common denominators, for the first fraction, I'm going to multiply by x. So x over x times 1 over x plus 4. For the second fraction, I have to multiply by x plus 4. So I've got 2 over x times x plus 4 over x plus 4. Okay, so the top is still the same for right now. On the bottom, we get 1 over 1x, sorry, because I had to multiply by that x over x times x plus 4. plus, notice it's the 2 times x plus 4, so it'll be 2x plus 8 over x times x plus 4. So now if you look at the bottom, those fractions have common denominators, and we can combine them. The 5 over x plus 4 is still the same on top of this big fraction. On the bottom, when we combine across the top, 1x plus 2x is 3x. So it becomes 3x plus 8 over x times x plus 4. Okay, so now what we have here is we have the top fraction being divided by this bottom fraction. So I can actually write this as a division problem. 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. And then we can treat it as a division problem like we saw in the last section we went over, section 8.4. So to do that, I change the division to multiplication and flip that second fraction. So I have 5 over x plus 4 times x plus 4 over 3x plus 8. And then I could simplify. So notice they both have x plus 4. Those would cancel out. And what I end up having left on top is 5 times x. And on the bottom, I have 3x plus 8. And that's it. That would be your final answer. So that's the first method where you get common denominators, so you only have one fraction on top and one fraction on bottom to deal with. In the next method, we try to get rid of all the fractions by multiplying top and bottom by the least common denominator. Okay, so for this one, I'm going to look at all the denominators. So I have x minus 5, x, and x minus 5. So it looks like for a common denominator, I need an x and I need an x minus 5. That would be our least common denominator. So I'm going to take this fraction and multiply top and bottom by that. So I have 6 over x minus 5 plus 1 over x all over 3 over x minus 2 over x minus 5. I'm going to multiply the top by x times x minus 5 and the bottom by x times x minus 5, because whatever you do to the top, you have to do to the bottom. Now, when you do this, you would be distributing this common denominator that you're multiplying by to both fractions. So looking at that, for the first fraction, you have 6 times x minus 5 all over x minus 5. So notice how those would cancel out. Okay, so you figure out what would cancel out in each fraction. So all we would have left there is the 6 and the x, plus for this next fraction, the x's would cancel out. So you would have 1 times x minus 5. Now on the bottom, when you multiply the first fraction by x times x minus 5, the x's cancel out. So you have 3 times x minus 5 left. For the second fraction, minus, you have the 2 times the x left because the x minus 5's cancel out. Now I would simplify all this. So I'd have 6x plus x minus 5 all over. We're going to distribute that 3x minus 15 minus 2x. So I get 7x minus 5 over x minus 15. There's nothing else we can simplify, so that is your final answer. That's it for notes today. If you have any other questions, be sure to contact your teacher.